As a proud cyborg, how can we only know FR4 today as a board factory? Let me show you the plates of these various types and colors. In price, the XPC sheet of 94HB is less than FR1, less than 22F, less than CIM1, less than CIM3, less than FR4. In fact, from the appearance, you can roughly see which are the same. The darkest XPC sheet is 94HB flame retardant grade, and this is the lowest flame retardant rating, that is non-flame retardant. So what is the difference between flame retardant and non-flame retardant plates? Let me explain with a simple, crude experiment. A sign represents flame retardant type AB for non-flame retardant sheet. Light with the lighter until there is a sustained open flame 10 seconds later. Remove the lighter and calculate how long it takes the flame to die. The extinguishing time of the flame retardant plate is 8 seconds, and the non-flame retardant is 24 seconds. A3 stands for F24. Here FR refers to the flame retardant specification code, but FR4 is a fiberglass version. And the flame retardant level of FRE set here is 94V, higher than 94HB. So you're the same brother but you're cheaper. This type of paper substrate is not high in heat resistance. It is mainly composed of wood pulp paper and phenolic resin. It is more suitable for such safe low-grade consumer goods as mice. Those who want to play this type of board need to pay attention to the temperature of the patch. You can't use things like reflow soldering, temperature of wave welding. It also needs to be strictly controlled below 258 degrees. Otherwise, there will be bad foaming plate bending. Look further back. The three similar colors are composite sheets. This HRF sheet alias half-wave fiber sheet. CIME is also mainly composed of corrugated cloth and wood pulp paper, and both of these are only single panel, and CIM3 can be double-sided. It is mainly composed of glass fiber cloth and glass felt. The performance of this composite version is close to FR4. It is often used in mid-range electronic products such as power supplies. Finally, the most commonly used is FR4. Different brands, different features, different prices, like different brands in the same TG value. Shenji is the most expensive. The higher the TG value of the same brand, the more expensive the price. This TG value represents the heat resistance of the board. Generally, the more sophisticated the multi-layer board, the higher the TG value is required. There is also a special type of copper-clad plate. It is a metal-based copper-clad plate, and the most commonly used is an aluminum substrate, especially in the field of lighting. It's as common as eating salt, because the copper layer in the aluminum substrate is higher than that in the ordinary copper-clad plate, relatively thick. Thicker copper layers mean greater current carrying capacity. The aluminum substrate has a high thermal conductivity, therefore aluminum substrate heat dissipation is very strong. But most aluminum substrates are single-sided and can only make patches. It's strong but it's not very strong.